LR parsers are more powerful than LL parsers. We have seen that LR parsers are broadly classified into 4 categories: lr0, slr1, lal1, that is look ahead lr1, and canonical lr1. Remember, this classification into 4 types is based on the construction of the parsing table. The general procedure for the construction of the parsing table is: given a grammar, take augmented grammar, create canonical collection of LR items, and draw the DFA and reduce the DFA to table. If you look at LR0 and SLR1, LR0 is least powerful because of the reason that it does not use any look ahead, whereas SLR1 actually uses a look ahead. That is the reason SLR1 is little better than LR0. But once again, SLR1 is also not very powerful. Among all the parsers, SLR1, LR0 are the least. So let's try to understand once again this LR0 and SLR1 by taking one more example. Let's take the example of regular expressions, an ambiguous grammar that defines all regular expressions with the main operations union, concatenation, and cleans closure. So if you take that grammar E2, E plus T or T, union, concatenation, and cleans closure. Let us now see how to check whether this grammar is ll1, whether it is lr0, whether it is slr1. How do we test whether the grammar is ll1? You remember what is the rule? When a grammar without null rules is there, take every rule. First of every alternative should not have anything in common. It should be pairwise mutually disjoint. Okay, and if you look at here there is a left recursion. Looking at the left recursion, we know that no left recursive grammar can be ll1. Hence, we can conclude that this is not ll1. Now let us check out lr0 and slr1. How do we do that? Take the grammar, take augmented grammar. What would be the augmented grammar for this? Add a production e dash to e. Now create canonical collection of lr0 and draw the DFA. So how do we start? Start with closure of augmented production with dot at the beginning. That means closure of e dash to dot e. What is closure of e dash to dot e? Because of the non-terminal e, take the rules from e. What are the rules you have in the given grammar? E plus t or t. Add it, because you cannot add it as a production. You need to convert them onto LR0 items. So how do you convert these productions into LR0 items? Simply by putting dot at the beginning. And remember, the closure rule is recursive. That means for every newly added item, you need to repeat this. So if you look at the newly added items, for E already we have added. Now if you look at T, because of T, add productions with dot at the beginning. And in the newly added items, now once again you have a non-terminal F. So add the productions of F with dot at the beginning, and this is I0. Now what are the possible transitions on different grammar symbols here? So in any state, the possible transitions could be whichever grammar symbol you have next to dot. For example, here it is on E, next on T, on F, and on A, and on B. So if you look at E, so here let's have even the end marker also along with the thing, because it is augmented rule. So E dash to E dot hash and E to E dot plus T. This is I0. Go to of I0 on E is find the transition and apply closure. So when you find the transitions, here there is a match, here there is a match. Whenever there is a match, move the dot next to that grammar symbol. Because the grammar symbol here is E, it matches only with these two, whereas in all the remaining productions, there is no match. Hence, when there is no match, it will not produce any new item. And so you get these two. Now if you apply closure on this, what you have next to dot is a terminal. Hence, it will not result in any other new items. Now if you look at T, on T it is E2 T dot T2 T dot F. Look at this state. Now because of F, F2 F star dot A dot B. Let this be your I1. Look at the state I1. What is the observation? In the state I1 there is a final item together with non-final items. Whenever there is a final item together with non-final item, what do we call that? That's a shift reduce conflict. Whenever there is a while drawing the DFA itself, whenever you come across any such conflicts, either a shift reduce conflict or a reduce conflict, immediately we can conclude that based on that we can say this is not LR0. Okay, and the best way even to check for SLR1 is here, before going further itself, you can check out whether this conflict can be resolved by SLR1. How do you do that? Actually, the best strategy would be when whichever state contains this conflict, create the table, LR table only for that row. So, if I take row 1, what are the different terminals you have? Plus, star, A, B and hash. Okay. So, what are the possible transitions from the state A? Suppose here if I take on F, it would be T2 F dot, let me just complete this, F dot star. Now on A, it would be F2 A dot. This is I1, this is I2, this is I3 and this is I4. Now if I consider on A, it would be I3, on B I4, whereas on F it would be T2 TF dot F2 F dot star. Is it matching with anything? No, it's a new state, so name this as I5. So to prepare that particular row entry, you need to first find out the possible transitions from that state, because the transitions on terminal refers to shift action. So put the shift actions here. So I1 on A is I3, that means 1 on A is S3. On B it is I4, that means on B it is the shift action S4. These are the shift entries. Now coming to reduce entries. Where do you put reduce entries? Remember, every final item, the action specified by every final item would be always reduce entry. So E2 T dot is the final item. So we need to place this as a reduce entry in the row 1. What is this number? We call this as 1, this as 2, so R2. So because of this final item, in the state 1, put R2 under, if it is SLR1, follow of E. What is follow of E? Look at this, follow of E is, here it is hash, here it is plus. So it's hash and plus because you have hash here and you have plus here. And do you find E anywhere on the right hand side? No. Remember, to find out follow set, you need to search for the non-terminal on the right hand side. Whereas to find first set, you have to search on the left hand side. So what is it? Hash and plus. So in the row 1, under hash and plus, put R2. Look at this. Do you find any multiple entries? So no multiple entries clearly indicates that the conflict raised by LR0 is resolved by SLR1. So just with this, can we say the grammar is SLR1? No. This particular conflict is though resolved, we need to check out each and every possible conflict. So let us complete the DFA and let us check out whether there are any other possibilities. Once again, if you look at I2, I2 also there is a shift reduce conflict. Here there is a final item, here there is a non-final item. So let me see on star, what we can do, F2, F star, let this be some I6. So if I go with state 2, what I can say, on star it is S6, T2F is R4. Where do I put R4? Under follow of T. What is follow of T? Look at this, follow of T is follow of E. So with that add hash and plus. In addition to this, follow of T is first of F. What is first of F? A as well as B also. Follow of T is first of F. First of F is A comma B. So put it under hash R4, 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 R4. Once again, there are no multiple entries. That means this conflict is also resolved. Now what else we get? We have taken this one on F, A, B, here on star. This has a final item, and coming to this one also on star, it is F2, F star, which is nothing but I6. Here also there is a SR conflict. So let us have even this state 5. So in the state 5, what do we get? On star it is S6, T2 TF is R3. Where do we put R3? Under follow of T. What is follow of T? R3, 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 R3. AB hash and plus. So look at the row 5. Once again there are no conflicts because all the entries are single entries only. So the SR conflict of state I2 as well as state I1 as well as state I5 is resolved. Look at this. In order to say that it is slr1, you need to check out each and every conflict. So just look at the DFA. We completed the DFA. All possible transitions. From I0, do you get any more transitions? Yes. On plus, you get E plus dot T. And because of T, TF, RF, and for F, dot F star, dot A, dot B. So let this be I7. Now here this one on T is what? E2, E plus T dot. Let this be your I8. Okay. Also T2. So here there is a match. Here there is a match. So T2, T dot F. Now because of F, dot F star, dot A, dot B. Look at this state. This is I8. In I8 also there is a final item and non-final item. So there is a SR conflict in the states. Look at this. SR conflicts in I1, I2 and I5 and I8. No doubt we have verified 1 to 5. Just with 1 to 5 we cannot say it is slr1. Even we have to verify 8 also. So let us see what happens with the row 8. So for that, first complete the transitions, possible transitions from the state. On A it is I3, on B it is I4, on F it is F dot star, which is nothing but, on F it is TF dot, yes, I5, it is I5. On F, TF dot star, which is nothing but I5. So here the entries are on AB, it is S3, S4, and look at this. Where do you put the final reduce entries? E to E plus T is R1. R1 should be under follow of E. What is follow of E? Hash and plus. So under plus and hash, put R1. Look at the row 8. Do you have any multiple entries? No multiple entries. The DFA of lr0 items is also complete, and we have seen that whichever state has the shift reduce conflict is verified and found that when you construct the corresponding slr1 table, we are now confident that slr1 is able to resolve all the conflicts. Hence now we can conclude that this is SLR1. So another example which shows the power of SLR1. Though this is not ll1, not lr0, but can be parsed by our SLR1, because this is the main advantage of SLR1. LR0 does not use any look ahead, whereas SLR1 uses a look ahead given by follow set. That is the reason what happens in LR0, whenever there is a final item in any state, in the complete row you are putting a reduce entry. That means possibility of multiple entries is more and more. How that is reduced in SLR1? In SLR1 we are placing that reduce entry not under every column but is restricted only under follow set. Follow set is used as a look ahead. Okay, that's the reason SLR1 is better than LR0. Okay. If you take any ambiguous grammar, remember an ambiguous grammar can never be ll1, can never be lr0, can never be even SLR1. Though we have not discussed look ahead LR or canonical LR, I can confidently say without knowing the procedure, it cannot be even LR1, it cannot be canonical LR1. To construct any LR parsers, we need unambiguous grammar. Let us check out this with an example. Look at this grammar. This grammar is ambiguous grammar. Let us check whether it is ambiguous or not. Take some simple input, something like AB, AB. How do you check whether the grammar is ambiguous? Take an input string. With trial and error, find out number of parse trees. If there exists more than one parse tree, we say grammar is ambiguous. So how do you construct the parse tree? S2. Suppose if I go with AS, A can be SA, S can be AS, A, B, A, B. A is A, S is B. Or I can go with AS, S is AS, where A is SA, S is B, A is A. Two different parse trees. This is different and this is different. AB, 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 AB. Two different parse trees shows that grammar is ambiguous. So when the grammar is ambiguous, let us check out whether it is ll1, lr0, SLR1. Let us test all this. Let us review all the three. So given a grammar, how do you test whether it is ll1? Take every rule. Check out whether first of each alternative production has something in common or not. So if you take the first rule, what is first of this? First of AS intersection B should be empty. What is first of AS? First of AS is first of A. First of A is A and it is also first of S, which is B. So the condition is violated. So with this we can say it is not ll1. Whenever they have something in common, that indicates there is a multiple entry in the row, in the column B. Hence it is not ll1. Now let us check out LR0 and SLR1. How do you test? Draw the DFA. Draw the DFA with LR0 items. Whenever you come across any SR conflict or RR conflict, there itself you can conclude about LR0. And to check out SLR1, verify as and when you come across any conflict, verify whether that can be resolved by SLR1. Okay, let us follow that procedure. Start with augmented production, S-2.S. Find closure of this. What is closure of S-2.S? Because of S, it is dot AS R. Now because of A2 dot SC R E. This is I0. What are the possible transitions? On S, on A, on small a and on small b. On S it is H dash to S dot, S to A dot S. Sorry, on S match is here as well as here, not here. Here there is a match, so move the dot, and here there is a match. So A to S dot A. Now because of A, add dot SA dot A. Now because of S, S2 dot AS dot B. So that is how we get all the items in I1. Now coming to on A. On A, here there is a match. So S2 A dot S. Now because of S, add dot AS dot B. Now here there is a. So A to dot SA or dot A. Let this be I1. Now on A it is A to A dot, which is I. This is I2, this is I3, and on B it is S to B dot, I4. That's all the possible transitions from the state I0. Now if you consider I1, possible transitions here are on A. Look at this, is it a shift reduce conflict? No, this is not for reduce action, this is for the accept token. So there is nothing like accept or shift conflict. So we don't consider argument production with dot at the beginning as a reduce action. Okay, that is not a reduce action, so it's not a shift reduce conflict. Now this one on A is what? A to SA dot. Here also there is a match. S to A dot S. Now because of S, S2 dot AS or dot B. Now because of A, dot SA or A. Look at now this state, I5. Do you have any conflict here? In the state 5, here there is a final item, here there are non-final items. Hence there is a SR conflict. So just by looking at this conflict, I can immediately say that this is not LR0. Now for SLR1, I need to construct the row for state 5. How do I construct for that? Find all possible transitions. On A it is I3, on B it is I4, and on S it is S2 AS dot A2 S dot A. Now A2 A2 dot SA dot B. Because of S, S2 dot AS dot SA or A here, dot AS and dot B. This is your I7. So possible transitions on S. Now on A is also there. On A it is S to A dot S, which is nothing but I2. So what are the possible transition, what are the column symbols here? It's A, B as well as dollar. Now look at this. From the state I5, there are state 5 and state 7 has SR conflict. Let us see whether this can be resolved by SLR1. If SLR1 is not able to resolve any one conflict also, we can say it is not SLR1. Let's construct for 5. So 5 on A is S3, 5 on B is S4. These are the possible shift actions. Now coming to reduce action. Reduce action is for the final item A to SA. What is A to SA? A to SA is 1, 2, 3, R3. So place R3 in the row 5 under follow of A. So what is follow of A? First find out follow of S. Follow of S is what? Dollar, because S is a start symbol. Then follow of S is first of A. First of A is A. Follow of A is first of S. First of S is here. Here you have B. And also first of A is even A. So AB dollar. Now let's see what is follow of A. Follow of A is what? First of S. What is first of S? Here it is B. You have A also here. So first of A is first of A. So first of A is A. Okay. So what you have to do, A to SA you have to put under A and B. So look at this. Here this is R3, put R3 under both. So at both places you have multiple entries, which clearly shows that this is not SLR1. Look at that, this grammar is not ll1, not lr0, not slr1 because it is ambiguous grammar. No ambiguous grammar can be ll or even lr. Grammar can be recursive for LR parser construction, but it cannot be ambiguous. Let's try to understand the power of slr1. Let's have one more example. Take this grammar and check out whether it is ll1, lr0, slr. Is it ll1? So look at this. First of each of the alternative, look at this. Here you have common B and B. So there is something in common. Hence it is not ll1. Two alternatives are starting with the same terminal symbol. Hence it is not ll1. There should not be anything in common in first of all the productions. Now coming to lr0 and slr1, draw the DFA. How do we draw the DFA? Draw the DFA with augmented production with dot at the beginning. Closure of h-2 dot s. What is closure of h-2 dot s? Because of s, add all the rules with dot at the beginning. Dot AA, dot BAC, dot DC, dot BDA. Now because of A, add this is I0. Do you have any conflicts in the state I0? No, all are non-final items, so no conflict. Now coming to possible transitions, it is S to S dot I1. On A it is S to A dot A. That's all. Let this be I2. On B it is S to B dot AC, B dot DA. Here there is a match as well as here there is a match. Now because of A, add dot D. Okay, and here no need to add anything because what you have here is a terminal. This is your I3. Now on D, S2 D dot C. Here S2 D dot C, and here also there is a match, so A to D dot. So look at this. This is a SR conflict. A final item together with a non-final item is SR conflict. And look, these are the A is over, B is over, D is over. That's all from state I0. I1 has a final item. Coming to I2, I2 on A is S to AA. Only one final item, so no danger. Now this one on A is S to BA dot C. Only one final I5. This one on C would be something like S to BA C dot. Let this be I6. Now coming to this one on D, it is S to BD dot A. Here and here both places there is a match. This is also another conflict, I5. Look at this, here there is a conflict, here also there is a conflict. Now this one on C, it would be S to DC dot I6, and I6 is already there. Sorry, this is I5, I6, I7. Let this be I8. Now this one on A, S to BD A dot. Anything is left? Look at this. Here you have a final item. 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 Hence that completes the LR0 canonical collection of LR0 items. So here in the state I5 and I4, I5 and I4, there is a final item together with a non-final item which is SR conflict. Hence we say this is not LR0. Now to check out whether it is SLR1, what we have to do? Draw the table for the two rows 4 and 5. What are the terminals you have? Small a, B, C, D and $. So if you take state 4, 4 on C is S8. So 4 on C is S8. Okay. Now what are the reduce entries here? Shift entry is on C. Reduce entry is A to D. A to D is number what? 1, 2, 3, 4, 5. R5. Place R5 in follow of A. So what is follow of S? Let us write down follow of S and follow of A. What is follow of S? Follow of S is follow of S is only follow of S dash, which is hash. Follow of A is what? Here it is A, here it is C. It is A comma C. Okay. So place A to D, which is R5. Place R5 under AC. R5, R5. So look at this. There is a multiple entry in the row 4. Similarly, if you look at row 5, on A it is number is I9. So S9. On A it is S9. Now A to D. So place R5 in the row 5 under follow of A. Follow of A is A and C. So R5, R5. Even the conflict of the state 4 as well as 5 both are not resolved because you are getting multiple entries. Hence you can say this is not LR0. Look at the grammar. A very simple grammar is given here. Such a simple grammar also cannot be parsed by SLR1. What is the reason? Though SLR1 uses a look ahead symbol given by follow set, actually the follow set is used independent of the state where it is in. And if you look at the follow set, actually the number of symbols in the follow set are larger than actual symbols what parser may see later. Since the follow set is larger, that means you are putting this reduce entry at more places than required. That's the reason still SLR1 is less powerful. Hence, to overcome this disadvantage, the better parsers are constructed with LR1 items. So far, the two parsers we have discussed with LR0 items. Now what we have to do is, we have to construct the better parsers. The better parsers actually uses not LR0 items, instead LR1 items. So let us see what is this LR1 item means.